Okay, we're going to delve a little closer into the periodic table. We're going to review today about those metals, nonmetals, and metalloids and where they're located on the periodic table. There's going to be something new that we're going to learn about, and it's how the periodic table is arranged to show properties, their chemical properties now, such as reactivity. So let's talk about what reactivity is. So the first thing is, reactivity is how easy an atom has a chemical reaction with another element. There's some atoms that are just very reactive and some that are not reactive at all. And that all depends on something we're going to call valence electrons. So we're going to talk about the valence shell of an atom, and you've learned how to draw atoms. And so we're going to look at the outermost level that has any electrons, and we're going to see if that shell or orbital that we've learned about is complete and full or not. If it is not full, it wants to be full. That's what all these elements are. They make compounds, and that's what everything on Earth is made out of, are elements that form compounds. Sometimes those valence electrons will share to make our full valence shell. Sometimes they will give their electrons to another element so that it will be a full shell, or sometimes they take them. But we really want to make a full stable orbital shell. So let's review what we've learned. We are going to have a sodium atom, which is Na, and we're going to have a chlorine atom. So our sodium atom is atomic number 11, and when we learned how to use Ape Man, we can figure out it has 12 neutrons. Since it has 12 protons, that means it has 11 electrons. Sorry, it has atomic number of 11, so it has 11 electrons. So 2 can go in the first level, 8 can go in the second level, and 8 can go in the third, but it only needs 1 because it has 11 electrons, because we've learned neutral atoms. Chlorine over here is atomic number 17, so it has 17 protons, and with its mass, we calculate that it has 18 neutrons when we subtract the mass from the atomic number from the atomic mass. That gives us 2 electrons in the first level, 8 in the second, and 7 in the third, because we need 17 total electrons. Well, if you look in the outermost level that it has electrons, this one has 1. Remember, this level can hold 8. It wants to be either completely filled, or if we lose it, the level below it will be filled. This one has 7, and remember, it can hold 8. So what happens in nature is electrons can move when they form compounds. That's what reactivity is. So when that moves over, I now have 1, 2, 3, 4, 5, 6, 7, 8, which is a full, complete shell. And now this shell no longer exists, and I have 8 on that second level. So you're going to find that 8 or full shells for the first level are very important. When that happens, this sodium atom now has more protons than electrons and will have a positive charge, and this chlorine element will have, more electrons than protons. It has a negative charge, and they will come and combine and come together. So let's look at another way that this happens. Let's think of water. Oxygen is atomic number 8. It has 8 protons, 8 neutrons, so it will have 8 electrons, and this is how we learn to do our Bohr atoms. Hydrogen has atomic number 1, 1 proton, 0 neutrons, so it's going to have 1 electron. Well, this first level can hold how many? 2. It's not full. This level here only has 6, and it wants 8. So what happens here is they can share. So now this level here has 2 for hydrogen, which makes it full. This level here has 2 for hydrogen. The first level makes it full. And now when I total all of these up that they're sharing, that's 8. And so this is what we call a water molecule in a water compound. So when we talk about reactivity, we're looking at the valence electrons, the electrons in the outermost level, and we're going to see where the periodic table tells us what the valence is without having to draw the atoms all the time.